Welcome to the video on answers to questions for revision, class 12 mathematics. 15 questions comprising of MCQ, assertion and reasoning, very short answer, long answer and case study questions is compiled from every topic. At this video, we will see questions from topics, relations and functions. Let us move on to the questions now. Question number 1. Let a finite set A containing n elements. The number of reflexive relations on set A. Now remember, the relations are nothing but the subset of cross product. Therefore, when you find the number of elements of the cross product, then the 2 power that will be the number of relations. Well, let us try to find the number of elements now. For that, the relation as ordered pair A comma B. Everybody know it is ordered pair. And the element A can be chosen in n ways and B can be chosen in n ways. When you want to find this ordered pair, therefore they can be done in n square ways. For all of you know that by the principle of mathematical counting. But in this pair, A comma A is also there. Whenever you select A, then you can select the other same element can come. Therefore, this will be n pairs. Therefore, the number of ordered pairs will be n square minus n. Now we have found the number of ordered pairs now. Therefore, 2 power this will be the number of reflexive relation. Therefore, the correct option is option D. You remember this, you can remember this formula also. The number of reflexive relations on a set containing n element is 2 power n square minus n. Therefore, they can ask it in the examination by giving the value of n also. For suppose if they are telling n is equal to 4, find the number of reflexive relations. There is no need to deduct the formula in the exam. You can directly use the formula 2 power n square minus n, therefore 16 minus 4. I think all of you know how to do it. Let us go to the next question. The relation R on the set A is given is defined as 1, 2, 2, 1, 3, 3. Now, whenever these types of questions are coming, don't try to find all the relations. You just check the options, whether you have to find all of them or sometime you have to check only symmetric and transitive. It depends on the question. But in this question, you have to check all of them because all the options are having all the three: symmetric, reflexive and transitive. Okay, let us now check reflexive. Very simple. 1, 1, 2, 2 is not there, therefore not reflexive. And 1, 2 is there, and similarly 2, 1 is also there, therefore symmetric. 1, 2 is there, 2, 1 is there, but 1, 1 is not there, therefore it is not transitive. Now you just select it now. Not reflexive, symmetric, not transitive. Which will be the option? Therefore, option C, symmetric but not reflexive and not transitive is the correct option. Whenever these type of questions are coming, you should be very carefully, quickly you have to find out which is not and which is yes. Based on that, you have to select the option. Go to question number 3. The function is given by f of x is equal to 4 plus 3 sin x. Is bijective, 1 to 1, not 1 to 1, neither 1 1 nor onto. Whenever you have seen that whenever you are having a sine function from R to R, normally it won't be 1 1 and onto. That is why in our inverse trigonometric function, we have modified the domain and the codomain to get inverse trigonometric function. Well, now let us take it to check one because you see whenever you are listening or learning a 1 mark question, remember the same question can come in 2 marks also. In 2 marks, you have to show the steps. Therefore, please learn it if it is a 1 mark question also, even though you know the option directly. To check 1, you know that you have to take 2 elements such that the elements are not equal, but their images are equal. Let us see what is f of 0. It is 4. F of pi, it is also 4. Therefore, 0 is not equal to pi, but their images are equal. Therefore, it is not 1 1. Let us go for onto. It is very simple. All of you know that sin x lies between minus 1 and 1. Therefore, 4 plus 3 sin x lies between 3 and 7. Therefore, the range lies between 3 and 7 only. Therefore, it's a closed interval 3 to 7, which is not equal to R. Therefore, range is not equal to codomain. Therefore, it is not onto. Therefore, it is neither 1 1 nor onto. Now, you can expect this question in 2 marks. Prove that 4 plus 3 sin x, 4 plus 3 cos x, like that, it is neither 1 1 nor onto. You have to prove it. You cannot directly select the option. Okay. Now I am showing you the graph of this 4 plus 3 sin x. Now all of you know that for two values of x, you are getting the same value of y on there, and it is not going away from that 3 to 7. That is why it is neither 1 1 nor on 12. Well, now let us go to the simplification part of inverse trigonometric function. You see, sine of cot inverse x. You have seen only sine of sine inverse, sine of cos inverse. All of you know how to do it. Now they want you sine of cot inverse x, sine of tan inverse x, tan inverse of sin x, like that. Now what you have to do is you have to put some substitution and you have to convert it. Let us see. Now I am taking y is equal to sine of cot inverse x, and let I take theta as a cot inverse x. Now y is equal to sin theta, it will become x is equal to cot theta. Now y is equal to sin theta and x is equal to cot theta. Sin theta is equal to 1 by cosecant. Now how to connect cosecant and cot? It is cosecant is 1 plus cot square. Therefore cosecant is square root of 1 plus cot square. Therefore this is square root of 1 upon root 1 plus x square. Therefore y is equal to sin theta and y is sin inverse of sin of cot inverse x, but that is 1 by root 1 plus x square. Therefore the option C is correct. Similarly, you can go for tan inverse x also. Well, go to question number 5. The domain of the function. Now remember, they are going on asking domain and the range of inverse trigonometric function. Now all of you know that sin inverse x, cos inverse x, tan inverse x, you know. But in the exam, they will ask sin inverse of some other function, cos inverse of some other function. You should be very careful. Remember, don't get confused with the domain and the range. Here they are asking you the domain. All of you know that what is the meaning of domain of inverse trigonometric function and range of inverse trigonometric function. Okay, let us go for the first. Let us start with f of x of sine inverse of root 1 minus square root of x minus 1. But remember, for anything sine inverse of any number, it lie between minus 1 to 1. That is the domain of f of x. Now all of you know that this is being made to have the principal branch. All of you know the idea. Therefore, here, remember, you have been given root x minus 1. Therefore, root x minus 1 should be always greater than or equal to 0. Otherwise, sine inverse of root x minus 1 is not defined. And minus 1 less than or equal to root x minus 1 less than or equal to, because it is sine inverse function. To club these two, we are getting the idea that root x minus 1 lies between 0 and 1. It cannot be negative. Well, okay. Now you just continue now. Now remember, whenever they are asking domain, mean they want the value of x. Keep it in mind. Again, I repeat, they want the domain of any function, means they want the range of x. Okay. Now what is x now? X lies between 1 and 2. Therefore, x belongs to 1, 2. Therefore, the domain is 1, 2. Now, you may be interested to know the graph of it. This is the graph of it. Now, in the graph, you are seeing that on the x-axis, the graph is only from 1 to 2. Therefore, it takes value only from 1 to 2. Therefore, that is its domain. All of you know the range. Range will be normally sine inverse x will be minus pi by 2 to pi by 2. But here, as it is having square root, negative side is not taken. We are taking only from 0 to pi by 2. Well, good. Let us go to the next question, assertion and reasoning. Here itself, you should be very, very careful. If the assertion is false, reason should be true. If the assertion is true, then you go for whether reason is true or whether it is the correct explanation of that. Based on the 4 options, you should be very careful. Now, let us go to the first assertion now. F of x is mod x by x is a bijection. What is the meaning of bijection? 1, 1 and on 2. Let us go to the assertion. Now, all of you know that this is the meaning of mod x by x. Mod x will be x when x greater than 0. It will be minus x when x is less than 0. Therefore, you have 1 and minus 1. 1 and minus 1. Therefore, for x 1, 2, I take two values which are not equal. I am taking f of 1. It is also 1 because it is greater than 0. F of 2 is also 1 because it is greater than 0. But for two values which are not equal, their images are equal. Therefore, f of x is not 1, 1. There is no need to verify onto, because you see, check the question. They have given that it is a bijection. If it is not 1, 1, it is not a bijection. Therefore, directly it is not a bijection. Therefore, assertion is false. When assertion is false, reason should be true, because there is no option that both are false. You may, I think it may come in the future CBSE question paper. But as per the recent one, A is true, R is false, A is false, R is true. These are only two options. Therefore, I think you just see the reason. Reason is very simple. It has given you the definition of a bijection if it is 1, 1 and on 2. Therefore, a reason is true. Or you are going for the option D, A is false, but R is true. Let's go to the next question, number 7. Maximum value of cos inverse x the whole square is pi square. Then range of the principal value branch of cos inverse x is minus pi by 2 to pi by 2. I think all of you can directly give the answer because reason is false. Range of the principal value of cos inverse x, all of you know that it is not minus pi by 2 to pi by 2. Therefore, directly you can go to the option that assertion is true and reason is false. But anyway, hold on. Suppose in the examination, if they ask for 2 marks, find the maximum value of cos inverse x whole square. Then you have to work out. Let us work out. Okay, let us go for the assertion. Principal value of cos inverse x is 0 to pi. All of you know that. Therefore, cos inverse x lies between 0 and pi. Therefore, cos inverse x whole square lies between 0 and pi square. Therefore, maximum value of cos inverse x is pi square. Therefore, assertion is true. But remember, the principal value branch of cos inverse is 0 to pi. Therefore, it is false. Therefore, assertion is true and reason is false. As I already told you, if the one of them is false, the other should be true. Anyway, I think this is as per the present char options. Okay, anyway, let us go to question number 8. So I think now I'm showing you the graph of it. Cos inverse x, the maximum value you are seeing, it is going up to at -1, it attains its maxima, and it is 9.87. All of you know that it is 3.14 something the whole square, pi square, 22 by 7 the whole square. Anyway, well, now let us go to question number 8. Show that f from n to n given by f of 1 is equal to f of 2 is equal to 1 and f of is equal to x minus 1 is on 2 but not 1 1. When these types of questions are coming, you are very happy because already they asked you what to be proved. Now, not 1 1. Therefore, you prove that for two values which are not equal, their images are equal. That's all. Simple. Now, very simple. From the given definition itself, 1 comma 2, if you take, their images are equal, but the elements are not equal. Therefore, it is not 1 1. Simple. For on 2, what you have to do? For every natural number on the right hand side, you should have a pre-image. For 1, you are having a pre-image. For greater than 2, for 2 also you are having a pre-image. For all the values which are greater than 2 also you are having a pre-image. Remember, this pre-image should be natural number. Whenever you take a number greater than 2, it is 2 minus 1, 3 minus 1. Sorry, it greater than 2 means 3 minus 1, 4 minus 1. Therefore, all are natural numbers. Therefore, there is no problem. Therefore, for every x, there exists a pre-image in the domain. Therefore, it is onto. Therefore, f of x is onto, but not 1 1. Let us go back to question number 9. Find the domain of the function. I think already we have discussed that domain question in 1 mark. Same thing can come in 2 marks also. Find the domain of the function sine inverse not x square minus x square. Be careful. Okay. All of you know that what is the domain? It ranges from -1 to 1. Therefore, be careful. Try to understand the difference between domain and the range of inverse trigonometric function. This idea should come in your mind. Okay, domain of sine inverse x is -1 to 1. Therefore, minus x square lies between -1 to 1. Therefore, when you multiply the throughout by minus, you know that by the property of inequality, inequality changes. Therefore, x square, 1 is greater than or equal to x square is greater than or equal to -1. When you put both of them together, 0 less than or equal to x square less than or equal to 1. Therefore, x square minus 1 is less than or equal to 0. Therefore, x plus 1 into x minus 1 is less than or equal to 0. Therefore, like -1 less than or equal to x less than or equal to 1. Therefore, the domain of the function is -1 to 1. Domain of the function is -1 to 1. I think you see the domain is same. Just like sine inverse x, it is same as sine inverse minus x square. Okay, shall we see the graph of it? Fantastic graph. All of you know what is sine inverse x. You might have seen that. It will be from minus pi by 2 pi by 2 will be there. Now you see it ranges from -1 to 1. Its domain is -1 to 1. Good. Let us go to question number 10. F from n to n minus 1, that is natural number except 1 to n defined by f of n is the highest prime factor of n. Show that f of x is neither 1 1 nor on 2. Be happy. They are asking you to prove it is not 1 1, not on 2. What you have to do now? You have to take two numbers such that the numbers are not same, but their images are same. Therefore, you have to take two numbers such that their highest prime factor are same, but the numbers are not same. Very simple. You can take 4 and 6. What is the highest prime factor of 4? 2. What is the highest prime factor of 6? It is also 2. 4 is not equal to 2. Sorry, 4 is not equal to 6, but their images are same. Therefore, f of x is not 1, 1. Let us go to on to. Very simple. All of you know that what are the collection of images? They are nothing but the range. Now, you are collecting only the highest prime factors. Therefore, range will be set of all prime numbers. Non-prime numbers will not have pre-image. Therefore, range of f of x, which is a prime number, is not equal to the codomain, which is set of natural numbers. It will be a subset. As the range is not equal to the codomain, the function is not onto. Therefore, it is neither 1, 1 nor onto. Let us go to question number 11. It is a function. Relation is defined. Show that it is a equivalence relation. You see, this type of equivalence relation will come in either 3 marks or it may come in 5 marks, depending on the length of the problem. Here, you have to prove reflexive, you have to prove symmetric, you have to prove transitivity. But prove them very, very carefully. Don't write the definition only, you have to prove it. Okay, now let us go for reflexive. You take an element a comma a. You have to check whether it is in R. That is, a is related to a. Yes, f of a is equal to f of a. True. Therefore, it is reflexive. You write the statement and check whether it is true. If it is true or valid, it is there. Otherwise, no. Let us go to symmetric. A comma b. A comma b mean a is related to b if f of a is equal to f of b. B related to mean f of b is equal to f of a. By taking the first statement, second statement is also true. Therefore, it is symmetric. Let us go to transitivity. Taking 3 elements, you assume a comma b, a is related to b, f of a is equal to f of b. B is related to c, therefore f of b is equal to f of c. From this equation, f of a is equal to f of c. Therefore, a is related to c. Good. Therefore, it is transitive. Therefore, reflexive, symmetric and transitive. Therefore, it is a equivalence relation. Good. Let us go to question number 12. Evaluate. This evaluation you should be very, very careful. You have to remember that sine inverse of sine of, if you get any value, that should be in the principal branch. Otherwise, you should not write directly. Don't write sine inverse of sine 3 pi by 4 is 3 pi by 4. Is it okay now? You should be very careful. Okay. Well. Now, therefore, you have to write 3 pi by 4 as pi minus pi by 4. Then, what is cos pi? Cos inverse of cos pi, you can write directly pi. But I am writing cos inverse of minus 1. And cos inverse of minus x is pi minus cos inverse x. Therefore, sine inverse of sine pi by 4 is pi by 4. Pi minus cos inverse 1 is 0. Tan inverse 1 is pi by 4. Therefore, the final answer is 3 pi by 2. These evaluation problems normally comes there, but carefully do it, because when one of one of your values is wrong, the final answer also will be wrong. Go to question number 13. This is actually a 5-mark question where a relation is given on ordered pair. Then you should be very careful with this ordered pair. It is not a single element A related to B. It is A comma B related to C comma D. Here, what are the mistakes normally you are doing? You are not taking the same element A comma B for reflexive. All of you are taking A comma A for reflexive. It is totally wrong. You have to take A comma B, prove that it is related to A comma B. I repeat once again, you have to prove that A comma B related to A comma B, not A comma A. Be careful. Well, now I am going for reflexive. I will take A comma B and I will prove that A comma B related to A comma B, and I'm just to prove using the same method which they have used. Now remember how they have multiplied. A multiplied with the D. First element multiplied with the fourth element multiplied by sum of second and the third is equal to, once again, second and third multiplied and first and the fourth added. Now you just remember like that, that 1, 2, 3, 4. For example, A, B, C, D, 1, 2, 3, 4. You can remember like this: 1 multiplied by 4 multiplied by sum of 2 and 3 is equal to 2, 3 multiplied 2 multiplied by 3 multiplied by sum of 1 and 4. If you remember like that, even it is highly useful in symmetric and transitive also. I have used it. Very simple it is. Therefore, it is true. Therefore, it is reflexive. Now, I am going for symmetric. The same thing I have used. A comma B related to C comma D. I am getting it. Now, I am just arranging the terms and I am getting that C comma D is related to A comma B. Very simple it is. Now, here reflexive and symmetric will be very, very simple. Even in transitivity, you should be a little bit careful. Therefore, when you prove this reflexive and symmetric, you may get only 50% of less than 50% of the marks allotted to the question. Okay, well, transitivity. I am taking first is related to the second, second is related to the third. I am proving them. And from the first one, I am dividing throughout by left hand side by BC, right hand side by AD. I am getting this relation 1 by C plus 1 by B is equal to 1 by D plus 1 by E. Similarly, for the second one, once again, I am dividing both by left side by DE, right side by CF, and I am getting the same relation. I am getting these two relations. I am adding them. When I add and when I take the LCM, I will get AF into B plus E is equal to BE into A plus F, which is nothing but A comma B related to E comma F. This problem is it has come in CBSE several times. So you can note down the problem, but here remember, if you write it clearly only, marks will be given. You cannot bluff simply telling that clearly reflexive, clearly symmetric, clearly transitive, marks may be cut. Okay. Let us move on to question number 14. Here you have been given a function f of x is equal to x upon 1 plus mod x is a bijection. What's the meaning of bijection? 1 1 and on 2. Go for it to check 1 1. I am taking two elements. And remember, whenever you take two elements, look out the domain. The domain is a set of all negative numbers. Non-positive, okay, non-positive number, whatever may be. Our mod x1 will be minus x1 and mod x2 will be minus x2. Till the end of this, you should remember mod x is minus x. Okay, anyway, let us put it there now. F of x1 is equal to f of x2. I am cross multiplying. I am getting x1 is equal to x2. Therefore, s is 1. All of you know that. Start with x1 comma x2. Assume f of x1 is equal to f of x2. Do the simplification. You should end up with x1 is equal to x2 for 1 1, x1 not equal to x2 for not 1 1. Good. Let us go to onto. What is the meaning of onto? You should take one y from the codomain. You have to assume it as y is equal to f of x. From this, deduct what is x and assume that x is allowed or not. Allowed means it is allowed in the domain or not. Well, I am taking y is equal to 1 plus mod x. All of you know that x is the mod x is minus x. I am cross multiplying and I am getting a value that x is equal to y by 1 plus y. And quickly you can directly write it because y is a number lying between minus 1 and 0. Whenever you substitute it in this y upon 1 plus y, definitely you will get a negative number only which lies between minus infinity to 0. But anyway, some book will prove like this also. They will find what is f of x by putting x value as 1 y by 1 plus y, and they will simplify and check out whether you are getting y. If you get y, the meaning is f of x is equal to y. Therefore, y is equal to f of x. Therefore, it is onto for 1 1 and onto bijection. It's okay. Well, it's a bijection. Now I'm showing you the graph of it. This is the graph of it. And all of you know that for two values of x, you are not getting different values of x, you are getting different value of y. Well, I think this is a very, very easy question case study. You have been given a situation where the children are planting rows of saplings and they are on straight lines. And you have to prove that two relations. For parallel relation, it is you have to check, and perpendicular relation, what type of relation it is. Now, first they want you L1, L2 parallel to L2, reflexive. Yeah, L1 is parallel to L1, therefore it is reflexive, therefore no issue. Go to symmetric. First is parallel to the second, therefore second is parallel to the first, therefore it is symmetric. Transitivity, first is parallel to the second, second is parallel to the third, therefore first is parallel to the third, therefore transitive. Therefore R is an equivalence relation. Now this question is also there in your textbook. A very easy question, therefore it is an equivalence relation. Now they are changing the relation now. The parallel nature is converted to perpendicularity now. What type of relation it is? Reflexive? Can a line is perpendicular to itself? No, it is not possible, not reflexive. Let us go to symmetric. A first line is perpendicular to the second, second is perpendicular to the first, therefore it is symmetric. Good. Therefore, it is not reflexive but symmetric. Let us go to the third transitive relation. First is perpendicular to the second, second is perpendicular to the third. Now let us assume that what will happen to the first and the second. This diagram tells you that first is parallel to the third. Therefore, L1 is parallel to L3. Therefore, it is not transitive. Therefore, symmetric. and not reflexive and not transitive. It is the nature of the relation number 2. Now they want you to just to check whether the function is a bijection or not. One is very simple. X1 is equal to x2. F of x1 is equal to f of x2, and x1 is equal to x2. Therefore, 1. And when you take y, then you are getting y is equal to x minus 4. All of you know that it will be definitely a real number. Therefore, it is a bijection. Therefore, f of x is a bijection. Good, last question. Now they want you to check whether it is 1. To check 1. Same thing, just we have done earlier. Take 2 x1, x2. Assume f of x1 is equal to f of x2. You prove that x1 is equal to x2 for 1. How to prove that range? It is very simple. You have to select the set of all images. What are the images now? Y is equal to x plus 4. X is equal to y minus 4. Therefore, there exists such that y is equal. It is a onto function. Therefore, the range of f of x is equal to R. Therefore, for the third question, that the alternate question, it is 1 and the range of f of x is capital. Okay. Thank you, friends. Practice more.